Alright, let's try another one. A ball on the end of a string is revolved at a uniform rate in a vertical circle of radius 70 centimeters. Its speed is 3.9 meters per second and its mass is 0.3 kilograms. We want to calculate the tension in the string when the ball is at the top of its path and the tension in the string when the ball is at the bottom of its path. Now, this diagram given with the problem also includes the forces acting on the ball at both the top and the bottom. So that's really helpful. So when at the top, the net force acting on the system is equal to, unbalanced, both of them are pointing down, is equal to MAC, because there's a center to this circle. Now, if I let towards the center be the positive direction, so this is something I'm going to set up. I'm going to let towards the center be the positive direction. That means that the tension force and the weight force, now it's written as mg in this figure, but I like to write it as F sub g, would be equal to A sub C. Now the question is asking us to find the tension in the cord, so we're going to find the tension in the cord. So then F tension would be equal to A sub C minus F sub G, and I know that F sub G is the gravitational force, also known as the weight, and it's equal to mg. So then F sub T will equal MA sub C minus mg. Now, remember, A sub C, the centripetal acceleration, is v squared over r. So then I can find the tension force as being equal to the mass, 0.3, times my centripetal acceleration, which is v squared, 3.9 squared, over r. Now that's 70 centimeters, so I need to convert it to meters by dividing by 100, and then minus the mass, 0.3, times the acceleration due to gravity. I'm going to let it be 10. So we get a tension force that's equal to 3.5 times 10 to the, newtons. So this would be the force at the top. Now, to find the force at the bottom, we're going to use the force diagram that was given here. So if I sum the forces at that point and letting towards the center be positive again, then that means that the sum of the forces is equal to MA sub C. And this time it's the tension force directed towards the center, but the weight force is directed away from the center. Right here is away from the center. So we're letting towards the center be positive. Therefore, away from the center would be negative. And that would equal MA sub C. Now it's that centripetal acceleration because it's kind of a special acceleration. So now, if I'm looking for the tension, I can rearrange and say that the tension force is equal to MA sub C plus mg. So then the force tension is equal to 0.3 for the mass. The centripetal acceleration is 3.92 divided by 0.7, just as we did before. This time plus mg, so 0.3. And for g, I'm going to use the approximation of 10. So here we get that the tension force at the bottom is 9.52 newtons. This is at the bottom. Now let's go back and look to see what this means. So the question asks for us to find the tension in the string when the ball's at the top of the path and then when it's at the bottom of the path. You may have had an experience before where you were swinging something around and you can almost feel the pull at the bottom is greater than the pull at the top. And so as we go around the bottom, the tension is actually greater at the bottom than it is at the top. And we're able to see that reflected in the values that we got for the bottom and the top.